should be another draft physics video production. DraftScience here on YouTube. Anyway, I guess it's going to be a photon kind of energy conversation, I suppose. Yeah. Yeah. That's what got chosen. So anyway, there was a comment in the spam folder, and it's just, religious kook kind of nonsense. But anyway, question everything, he calls himself. It's just, world's just full of people who, liars. Obviously you don't want me to question your dopey, weird theories. Anyway, force, physics, does not exist. Whatever. Physically, in the same way that an object with mass. So I would argue you have it exactly backwards. The objects with mass don't really exist. They're just a collection of force. So much of this crap, like I said, they never really thought about any of this stuff. They got some vague notion of a theory and then just said, well, we have a vague notion of a theory, that's enough, let's stop thinking. And all of this stuff Newton already did, which is ironic. I mean, certain elements of this thing. So the idea is, let's say I had a container, all right, and it had elements in it, okay, already, some sort of movement, bits moving, and then I, from the external world, added some energy, hit the box even. Let's just say I even just hit the box, and I dented it. Okay, I put a dent in the box. That dent means that some portion of the energy, that is stuff that was going this way, is going to hit this surface sooner than it would have before, and it's going to go back and it's going to end up here sooner than it should be, and then it's going to, if it goes over here, it's going to end up here a little sooner than it should be. And so in a sense it's going to be a piece of added energy. So if you thought about it as an empty box, and you were just going to inject some sort of perturbation, some action, and the action would continue to move. And the idea is it would just perfectly reflect inside the box. You could kind of understand that all of this movement, so everything else is dead, and all I did was make one dent in the box, that this dent would just keep moving. Like, let's just say that it can change direction without any losses. It would just keep going and going and going and going and going, and that would be what we call heat. But it's, it's energy in a sense that I've now caused motion. And the universe is technically doing something very similar. A little bit of this goes in, it dents something, it causes an action, and the action can stay in a place or the action can leave. So if the action leaves, then you have something going the speed of light and nothing really changes. Or if it doesn't leave and it gets stuck in here, then this doesn't get where it was going. So this was going here, okay, and it didn't get there. And that has a consequence, because now some other box isn't going to have any activity in it because it's not going to get pushed. And then you can understand, though, if the two boxes, if I had another box and the two boxes were connected, you might understand that this box is going to have a tendency, okay, because of the initial action was in this direction, to do this, and that action can do this to another box, and they can just transfer this motion from box to box. And that's sort of what atoms are doing in terms of transferring stuff moving the speed of light into boxes moving a lot less than the speed of light. A box moving a little bit, and then those two boxes are connected with a bunch of stuff going back and forth, you could argue. And so there's another box, and this box just essentially moves this line, you move this line, then this line moves out here, and then that ends up moving this line out here, and so on and so on. And you can get this idea that the energy outside causes action inside, and that causes action outside, and that causes action inside, and it's just the action. This stuff, when it's in all directions. So you can sort of understand this as a velocity argument in the simple sense that when you give something velocity, right, you're changing its internal disposition. So if it had mass going this way, and it has some stuff bouncing around going that way, and it has stuff going that way. So every direction it has stuff going back and forth. And you could sort of understand that what motion really is just changing the bias. It's giving it less mass in one direction and more mass in another direction. So when you shoot a bullet out of a gun, you're sort of saying that, well, what you've done to the little bits inside, the little atoms, or more specifically the electrons and protons, is you've given them a bias where they have a lot of mass this way. You know, if they hit you, when they have velocity, they hit you like, wow, that thing weighs a lot. Like the bullet weighs 10,000 pounds. So the real weight of the bullet is, say, 10,000 pounds. But when it's spread out going in all directions, it only seems like 1 ounce, right? Because they all balance each other. So it seems very light. It doesn't seem to have much weight, much mass. But if I get all of its stuff going in one direction, right, I get it going faster and faster, it gets heavier and heavier in the direction it's moving, and it obviously gets lighter and lighter in the directions it's not moving. I mean, you can barely feel its mass, and it certainly has no mass this way. If I put a scale here, I'm not going to measure any mass at all, right, because the bullet's leaving. It's not going to put any pressure on the scale at all, okay, and this way, no. It's disappearing from reality, essentially, in these other directions. It has no pressure to apply, but it has lots of pressure in that direction. See, the pressure, the weight, is really just like if I have a scale, a standard little scale just sitting there, and I put an object on it. All you're really weighing is, the imbalance created. And it's balanced. The little object, you could say, has got the same balance as the scale. But gravity, of course, is doing the gravity thing, and it's changing the balance. And that's what's making the thing move. And that movement, even though it's just internal, it's still pressure, and that's what's pushing on the scale. So it's not really a measure of its weight. It's just a measure of how much gravity can change the things inside here. How much the gravity force, the extra amount of energy going this way versus going back up, how much that imbalance is, and how hittable the mass is in terms of how many of these little blobs of crap it has. So that's why atomic weight is relevant to your material weight, and again, your capacity to be affected by gravity. So gravity is essentially a nuclear force. It's affecting the little electrons and the protons. It's making them move. And it's this force. Same thing as photons and magnetism and gravity. They're all the same thing. They're this stuff, moving the speed of light, kind of quite obviously. And so, Newton said, a force acting on it. And he considered a bullet a force. Now, would you have to understand that? No, well, the force is the little bits inside the bullet. The force is the stuff that move the electrons and the protons. Technically, that you could call the cleanest version of the force. And you're just saying there's people in a car. You know what I'm saying? It's like people are people. You can put them inside of a car, okay, but they're still people. And, and if it was like the Flintstones and the people had to use their feet, to make the car move, it's the force making the thing move. The thing doesn't have any force unless it has people in it, with their little feet going back and forth, and moving the car. So everything is the force. The force is the real player, and the matter is just the fact that you've taken that force and put it inside, like, say, a dead shell, little deaditons, photons that aren't going the speed of light. You can just build the box out of that, and that would suffice to create the mechanism. Now, the other part of that conversation gets tied. See, all this stuff ends up tied together, and that's why my theory must be right, because it goes across all of these things and creates solutions to all of the physics problems, blah, 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 blah. So conventional theory would have you believe that electrons go speeding around at incredible half the speed of light or 3/4 the speed of light. That I could shoot them out a cathode ray tube or something, and there's actual electrons flying through space at these incredible speeds. And the truth, I think, may well be, is that that really doesn't happen. It's always the force that's going these really fast speeds. And all you're really calculating is when a big pile of force, that is when you have a whole bunch of elements of force hitting something, it makes it move a lot, okay? Because all of these little soldiers give it a push. One soldier pushes, another soldier pushes, another soldier pushes, another soldier. They just keep pushing, pushing, pushing at a much higher rate than the stuff coming this way. So they're pushing it, and they just keep pushing it, and that's, and so that's how we detect what happens. Like we have cloud chamber images, and the images is that, there's always this catch, where they'll see something go like this, and they'll see it fork. But this, they didn't see what this was. So this, you could say, yeah, it hit something here. That's an obvious hit. But this part, when the line starts, that can look to them, because it went through a piece of lead or something, that can look to them like, oh, that was a particle, that was an electron or a proton or some other kind of thing, when no, that could just be force. And this is where the force hits something. That could just be a stream of the force. So what's going through the cathode ray tube is just a bunch of force going through the tube, and that's why it's always moving very fast. See, I'm still this is draft. I mean, I'm not going to make any solid assertions yet, but there's a lot of experiments and a lot of detail. But what I've pondered is that there is no experiment where you create a potential difference, a plus and a minus, and you send, some, well, it's got to be the other way around, realistically, a minus and a plus. And you send some electrons on their way. So you go from one plate to another plate, say in a plate with a bunch of holes in it. So some of the electrons go through. And what they don't come up with is some way, what you don't see is, this is the gun part. Shoots, the beam comes out this way. If you can see that, yeah. What you don't see is this stuff moving like 20 miles an hour or something. You don't see these electrons moving ever at like some really slow speed. They're always going really close to the speed of light, and that's sort of an indication that they're really not electrons. It's just force you're pushing through, and there is no electron there. You're just saying there is because there isn't much difference between an amount of force hitting an electron and an electron hitting another electron. You're not going to be able to tell those two events apart, frankly. It's not going to be distinguishable from the methods we have to detect something. So we really can't detect the difference. So like cosmic rays, they say they're protons now or something, going through space, and they get here and they hit something and it creates a lot of energy. Well, how do we know it was a proton? Because the way we're detecting it is we're saying, how much does it move another proton? How much is another proton moved when it hits another proton? How much does it move? Well, how can we tell whether it's the real force that's pushing it or whether it's just another proton hitting another proton? We can't tell the difference. So there's reason to be suspect about the whole Bohr model of the atom. That electrons are doing all this whipping around things. The electrons are flying everywhere. They're going around and around and around these supersonic kind of speeds and doing all of this fast shit. And there's real reason to doubt that's ever happened. They just made up the model because it looks like a solar system. It seems like, looks like, it seemed a little bit like, blah, blah, blah. And so you really shouldn't be trapped into that notion because the evidence hasn't really demonstrated that any of that really happens. There's no hard evidence demonstrating any of those functions. And, technically the only way you can really make electrons move slowly is when you put them in a plasma, which is when you take a bunch of atoms, with nucleuses and electrons stuck to them, magnetic positions, and you move the atoms, okay, in the plasma, and the plasma sparks. As you move all the atoms, they create photons that come out, and so it, and so the whole plasma can move really slowly, and it's energized because the atoms are bumping into each other and they're ionized and blah blah blah, and that makes it possible to create photons, extra energy to leak out. This is not a very good atomic box. The atoms aren't connected to each other strongly enough, and therefore when they interact with each other, they break off little pieces and cause the underlying force. The force is in their little boxes. The atoms are a box, the electrons are boxes. So if you think about it all, it's a bunch of boxes inside of boxes. You could sort of understand that if you can get something to go into a box, but then the box could leak. And then eventually this box will leak that out. So it's just leaky boxes. So, we'll read some more, see what it's necessary to add. You haven't got through 10 words yet. Okay, force does not exist physically in the same way that an object with mass. So I'd say that's just wrong. So again, these people who make statements and then they back it up with no correlation to experiments and no citation to experiments. It's just not very useful. Well, not useful at all, actually. Thus making it not the initial cause of pushing. Doesn't matter initial. So you think you have evidence to dictate how the universe was created and in what form the accident, the error code, whatever it is, happened. So this is like somebody walking into a really complex plant that builds cars or something, and it's got all kinds of conveyors and all kinds of things, and and kind of diagnosing. Everything's broken and flew apart, and you're going to just walk in and say, oh yeah, well, I say it happened over there, I say it broke there, I say something went wrong over here. There's no way of diagnosing, in my opinion, origins. Just no point. You can imagine the steady state, where it just oscillates. The bubble gets bigger, the bubble gets smaller, bubble, blah blah blah. The pressure changes. And I've sort of stated that this energy never dies, and all you do really is when if you have a bunch of the stuff in the box moving, okay, that means there's less stuff out here. Okay, so that would be one way of understanding it, is that all you really do with gravity is the universe, the G, big G in gravity changes with time. As the matter spreads out, as galaxies get bigger, they're losing energy to the universe pressure, and that pressure eventually will push them back in again. So the universe just oscillates forever and ever and ever. So there's lots of ways to understand this where you don't even need an origin of the universe. But it doesn't matter. You're not going to answer the question with anything rational. You're saying, because we can't see that, can't even barely imagine it, therefore God must have done it. Some kind of thing that poofed out of nowhere, that existed forever, that didn't have a birth. I mean, it's just a non-answer to the question. It's just taking the answer, putting it over here in invisible space. It's analogous to sweeping a problem under the rug. You're just pretending to solve it. You didn't solve anything. You just took the question, the difficult question, existing, and you just shoved it under the rug with a stupid God answer that doesn't explain how God exists. I mean, it's just stupid, and really a really dumb God. I mean, not like a really cool, intelligent thing that knew everything. No, some idiotic God who puts cracks in sidewalks so people can fall into the street, get run over, and then somebody can learn some idiotic life lesson and go to heaven. I mean, just some kind of bizarre, stupid God that thinks there's some point in harming little sensitive creatures. I mean, you're so pathetically stupid. All right. Initial qualities are pushing. There's no pulling. shaping objects, motion, work, or being a vector quantity. Well, these are none of the words I use, so who you talking to on my channel? I mean, what's the fucking point? You either address my physics or you fuck off. So, yes, this comment belonged in the spam folder. Thank you, viewers, for spamming him. Anyway, in physics, the word force, as we know it in physics, like you're a physicist, my ass, as we know it, turns out to be nothing more than an expression to express the idea, like when one would use the word love to express one's feelings. Well, it's exactly the opposite. I'd say it's a pretty explicit kind of concept, in that we know force is connected to the thing called velocity. That's, its momentum and its mass, its capacity to be affected by the force, to absorb force, its solidity, its ability to be pushed, all of those kinds of things. And so it's much more explicit than any concept of whatever attachment the word love means, whatever that is, addiction, Anyway, but physics and in mathematics, screw that. Like there's no vision in mathematics. It's a model that is so pixelated, so simplified. It's like saying, okay, that's a picture of Rob Lowe or something. No, it really isn't. Screwing 12-year-olds. Anyway, physics and in mathematics still use force as though it was something physical that could enable the initial cause of motion, making it counterintuitive. Well, to you it's counterintuitive. To me it makes perfectly good sense that that all other motion in the universe, anything moving less than the speed of light, isn't a force, it's a container for force. And all you're doing is measuring how much force it has going one way versus how much it has going the other way inside the container. And that's it. Alright, example. Without applying... example. Well, it won't be an example from a physical experiment, that's for sure. Without applying the energy from within you, whatever that could possibly mean, choose an object of your choice to push and pull by simply applying only the force or the net force. Well, again, no one who's arguing that the ability of objects to interact has anything other to do than you have to physically put electrons next to electrons to engage charge and other phenomenon that are going to be able to convey pressure between objects. You can't create pressure till you make the objects very close together. The pressure out here is nothing. You have to really compress the locations of the boxes before the boxes have an ability to communicate with each other in terms of creating force between them. So that's just sort of a bullshit argument, frankly. Okay, and if you pull on anything, it's going to be a push. So again, what's your example of a true pull somewhere? Where did I ever pull anything in my life? Because I didn't. Even when I'm pulling on a rope, I'm pushing on the rope. I'm actually pushing the rope in a direction. I'm not pulling it anywhere. Anyway, meaning the energy, applied energy, is the origin of motion and not force. Well, frankly, you're not understanding if you don't think force is energy. So that's really stupid. And energy is just a word for when force is imbalanced. When a system has balance, it's understood that it has nothing we would call energy, because the sides are getting hit by the same amount of stuff. We're not measuring how much stuff. There could be lots of what might be called energy in some other circumstance, but it's not energy when it's defeated itself. Like if a laser beam shooting this way and one shooting this way on an object, then the object just stays where it is. Now, it doesn't look like it has any energy because it's staying where it is. But the fact is, its environment means that if you just change it a little bit, you create an imbalance, then we'll have what we call energy. But the energy is really just recognizing balance and imbalance. A system's balance. If it's out of balance, it's moving. If it's not out of balance, it's staying still, relative to your balance. All right. Once energy E is applied, it creates what is known as momentum P. Yeah, velocity and mass. Okay, there's no secret to that. You have to change the mass. The object has to have force put into it. It has to have its arrows reoriented. So when the space shuttle takes off, that's what that big flame going out the back end is. The big flame is saying there's lots of arrows going this way. And to create that imbalance means there's a bunch of arrows going this way. Okay? Because you can't destroy the net balance of a system. You can only send some energy this way and some energy that way. You can, it's all got to go somewhere. And so the trick is to segregate the force by sending the stuff you want in one dimension and sending the stuff you don't want in another dimension. And that way you can defeat the system's will, so to speak, to be balanced. Anyway, momentum P. When the momentum object is in motion, comes in contact with another object, it makes the surface contact. There's no surface, there's just electrons and protons, so it's making contact with what's the reason why the universe is push is because electrons push on each other. Electrons are always on the outside and they're always kind of hostile, and that's what makes it possible for things to be non-transparent, is the electrons just will not allow other electrons to invade their space. Comes in contact with object, it makes the surface contact that will enable you to push and pull. Again, there's no pull anywhere, so it just doesn't exist. It's a figment of bullshit. It's a fake concept. Like there's no night, you could say, right? There's only day. There's really no night. There's no thing that makes darkness. It's the absence of something. Pull is the absence of a push. There is no pull. Example, EP equals MA. So mass times acceleration equals energy times momentum, which doesn't make any sense, but whatever. And so on. Note, EP is not to be confused as kinetic energy in any way. Yeah, well, whatever. It doesn't really matter. We know what the momentum is made out of, and that is a force has to give something momentum. It doesn't just have it. The only thing that just has momentum is the force itself. And you can't kill the force, and that's what I'm sort of trying to illustrate there. Is the force goes in, and it never dies. It's always an arrow going somewhere, and you can trap it. And that's the simple truth. You can trap the energy in a little quiet place. You have a box. You can put the energy in the box. It's trapped in the box, and you can let it go anytime you want. Just like a nuclear bomb, you can just all of a sudden say, let's break the boxes and let all the energy out. Well, not all of it. A tiny fraction, as it turns out. Let's let a tiny fraction of the energy out, even though that's going to be incredibly destructive, just letting a fraction of it out. All right. Momentum represents things like work, wave, gravity, light, lightning, tsunami, earthquake. Well, this doesn't mean anything. Yes, physical matter has momentum. Atoms, in most cases in our real world. And I would argue that that's just little electrons and protons moving a little bit at a time. They have to be forced to move. They don't move without being forced to. Okay, without energy, there's no momentum. Let's say again, that doesn't make any sense. But of course, without imbalance in force, that is, without hitting something with more light from one side than the other, it won't move. That's true. Without momentum, there is no surface contact on an object, so this is more nonsense. Again, there's no surface. There's none of those things exist except on the nuclear scale. The electrons and the protons are the only things with a surface. Nothing else has a real surface that's anything other than electrons. Okay. Contact on an object to push it, pull, work, shaping object's motion, gravity. whatever that is, mush, 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 etc. Momentum does not and cannot exist without applied energy. Well, again, applied imbalance in force. I mean, you're just such an arrogant turd to say all this shit and not cite a single experiment, not a single thing to illustrate what you're fucking talking about. Anyway, momentum does not and cannot exist without applied energy that creates it. Again, energy is force. There's no energy without forces being involved, and all energy really is a word for when you can change the balance of a force in a box. So you can take a box and you can put more force in going one way than it's going the other way, and the box will move. All right. Then without EP, what? I mean, again, energy times P, which was momentum. That doesn't make any sense. All fundamental forces of nature would be inert and non-exist. Non-exist. So again, this is just more mush. You don't change the fact that the boxes exist by taking all the energy out of the system. So they'd still exist. They just wouldn't move anywhere because there wouldn't be anything to force them to move. Okay, energy is energy. Oh, that's really clever. But it's when energy, E, is being applied. So this is more nonsense, like there's a magical energy thing and you can apply it or not apply it. The only way it's applied is through the word force, asshole. Okay, that's when it's being applied, is when you can understand it as a force. And again, the way you negate the energy is to have two equal forces, and then you won't see any energy. Alright, being applied that creates the momentum. Okay, energy is energy, but it is when energy is being applied that it creates the momentum. No, it's when you create an imbalance in how many bullets you hit something with. If you're shooting a gun one way, and another guy shooting a gun the other side, and the thing doesn't move, right? But if I change how many bullets or how fast he's shooting the bullets, well then the thing's going to move. And that's all energy is. By applying the right amount of energy, nothing is immovable or unstoppable. So it's in a more nonsense, like, well, yeah, but how much energy does the universe have in it? There's not an infinite amount of energy. So this whole nonsense that you have an infinite number of bullets somewhere to move the infinitely big object, no, you don't. So that's just bullshit. There's things that are unmovable and unstoppable because they're just too big, and you can't hit them with enough energy. You can't create the imbalance to push them. Whatever. Galupi Guerrera, who cares? Jeez, people, so fucking stupid. Anyway, alright, so some guy called Jim. I think it's interesting how someone who claims to care about making arguments and not appealing to fallacies, another pile of shit there, has a bunch of followers who all think we should bring back duels, especially in the context of deciding which scientific theories to adapt. I don't think anybody's saying that. I think what people say is liars suck. Okay, they absolute suck. Okay, and assholes who can't make a stand-up argument. That is, they can't argue your physics. They can't argue what you're saying. They're going to argue, how long your hair is or some other kind of nonsense. Well, those people should be shot. That's basically what they're saying. They're saying that little turdy losers who can't make a rational argument and can only make ad hominem attacks and false claims and lie about somebody else, they suck and they should be shot. I think that's perfectly reasonable. Yeah. Liars suck. They just absolutely suck. It's kind of the first crime you can commit is, lying. It's just too easy and too stupid, and it's just a ballless tactic. Okay, as if the guy with the biggest gun. So you think that's how duels work? No, duels are kind of like this fair fight thing. You both stand there with the same gun, same bullet, and you're sort of just saying that I'm not going to live in a world with you lying scum. Okay, so you either stop lying or I'm going to kill you. Okay, and you can kill me, but one of us has to go, because I'm not going to sit there and live on a planet with scumbags. I'm not going to support a government that feeds you. I'm not going to do anything. I don't want to interact with you. You are scum. All right? So it's just basically saying to somebody, no, you're too scummy. It's a war. It's a little private war. You're just basically saying, look, we told the Nazis what you're doing is unacceptable. You can't be locking people up in these concentration camps, putting these little Star Davids, tattooing them, all that bullshit. Fuck you. You can't have this second-class citizen shit. You can't own slaves. There's things we said you can't do anymore because they're just too fucking stupid. All right, and one of them is fucking lying. Some people with personal integrity say, I'm not going to stand around and let you be a motherfucking liar. All right, not about me. Fuck you. Okay, lie about your fucking slut mother, but don't bug me with your fucking lies. Right? Anyway. So it's nothing about the biggest gun automatically wins. No. The point is that people of integrity need some way to force people without integrity to man up. And frankly, if the law ain't going to do it, then men have to do it on their own. Okay, I think there should be a law against people like you, lying scum. It should be perfectly within my rights to say, where did you get that fact from? How do you think it has any truth value? Well, you're not allowed to say some kind of shit like, your mama's a whore, okay, for example, unless you can prove it. So, obviously I don't walk up to people and say your mama's a whore to win an argument. Okay, I say it to liars just to point out that we have no evidence that Jim isn't a pedophile. He has sort of a pedophile look, blah, 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 blah. Yeah. Just saying. Remember, okay, let's see. The guy that has the biggest gun automatically has the best physics theory. So then he brings up Nazis, which is really stupid, right? Because it's a sad fact that in our wars, we don't have fair fights, as nations. We just beat the shit out of people because we have bigger gun. And that's really rude. That's kind of ballless, dropping your bombs on the little village people, from your F-15s. It's kind of lame, It's kind of a gutless way to win a war. Not very manly, anyway. Anyway, the physics theory. Okay, remember the Nazis were probably 2 weeks from testing nuclear weapons. Well, where'd you get that fact from? I think that's probably a pile of shit, actually. When they surrendered at Nuremberg. I thought it was Nuremberg, but anyway. Health. I don't know what that means. Might does not make right. Yeah, well, you're saying lies do. So, lies don't make right? Wrong. Lies are wrong statements. I don't know how that makes right. You fucking liar. All right, anyway. Sorry to bring up Nazis. I don't think you're sorry at all. I don't think you care about anything. I think you have a piece of character anywhere in the location of you. Okay, nothing. All of your electrons and protons are scuzzy. Anyway, Nazis in the context of this channel, but when you're a Holocaust denier, maybe you deserve to be called out. So again, there's no evidence that I've ever denied anything called a Holocaust. That is the idea that millions of people were brutalized and killed. Okay, and that the Nazis did it on purpose in the sense that there was a point in the war where they basically said, yes, if you can't work them to death, find some other way to kill them. That really happened. But 6 million people were not gassed to death. That didn't happen. Okay, so I'm not denying anything called a Holocaust. I'm denying that people tell stories in any kind of realistic way. They just do the fish thing. They go fishing and they talk about the one that got away, and it was this, and they were so heroic, and they saved 17 people from drowning, and they did all kinds of things because there's no way to check the story. So they make it, Jesus walked on the water. He rose the dead. He did lots of things that, even if you think there was a Jesus, you're probably saying, no, I don't think he did any of that crap, because why would his disciples turn on him? If they really saw him do all that shit, they would know he was God, and they'd know, well, I have to do the right thing. They wouldn't doubt, if they saw that shit. So anyway, this is all just to, you're just full of shit. You suck. Get what you deserve, which is to be lied about chronically. All right. So the rest of it's just bullshit. So let's see. What the hell? Some sort of existential time warp of metaphysical import. There's no metaphysics, Bill. But anyway, so I guess I'll jump ahead to another subject. I think it's on this page. Yeah. So this whole ring thing, like the interferometer. Okay, this pattern. I pointed out before. So this is like a 1980s paper. 1981. There's so few papers written on this subject. And there's a little brief, cruddy Wikipedia argument on the subject. This isn't even the right one. Where the hell was the Wikipedia page? Here we go. So, so this is something Newton had already discovered again. Okay, and they gave it some other guy's name, Quitlet or whatever. Quitlet rings, but they're basically the rings of the interferometer. So it's they always give these names, and they're always crappy names like Fontenary, diffraction, and they all have these unpronounceable names, which is really quite annoying. So anyway, so the idea is, and like I said, Newton had already discovered all this shit. And because he didn't posit an explanation for the phenomenon, somehow people just forget that he already was aware of it, and it was a part of the physical reality that they knew about. So the idea is that you have this ring pattern that's created. And it's basically the two-slit experiment, right? The two-slit experiment is basically just taking this as a view of the pattern. So you're just seeing this is a bar, and this is a bar, and this is a bar. Well, that ends up being the whole lit up center anyway. And this is a bar, and this is a bar. So it's basically the same thing. And really what it has to do with the two phenomena. So first phenomenon being that light is diffracted, that is, it's sent to various locations. Like it can hit something, an electron, and depending on how it hits the electron or what pressure the electron's in, the electron moves when you hit it, okay, and it moves in such a way, all right, that the new photon is released. So it's like the electron's here, and it'd be nice if it just moved straight, but it can't move straight because let's say there's another electron here, and there's another electron over here, and another one here. So when you hit it, the electron moves this way instead, all right, and then when it goes back to this position is technically when it releases the piece of energy that's part of the photon. So it's a piece of a photon. It's not the photon. It's just a piece of it. So the idea is that this amount it moves really just has to do with subtle variabilities in terms of where this is. So this movement can be, a little bit of a spread, okay, either way in some cases. So it can go, these directions. So that's this diffraction, is the spread. And then the other part to it is the fact that you're going to take light that's spreading from some other place, and those two are going to intersect at certain points, and that's where you're going to see a photon being rebuilt out of pieces of photons. Let's see if there's another way to say this. Alright, so I've sort of pointed out that the half-silvered mirror is essentially a bunch of little slits. Okay, so the thing they use for a beam splitter, that's why it has the same pattern as this pattern. And the argument is that, you could think of these slits as just being, this half-silvering as just being dust on the surface. Because the only part that matters is this part, right? We don't need this reflection part. So this doesn't have to be half-silvered. All you really need is the diffraction part. All right, and the idea is that each little slit from pieces of dust, are going to keep creating these same patterns. And so what it's really doing, though, in space is that the light is coning. That is, there's an object, and the light goes around it, so to speak. Okay, I'm saying the end result is you could think of it as the, well, it's not right to think of it as a particle, because you're really talking about hitting the space between the particles. So it's really just a bunch of single slit experiments. You're basically just pointing out that you can send, you can create this ringed pattern from one single little slit. So if you did, because you say it was a round hole here, right? Instead of one of the, instead of using a slit, you just use a round hole. The idea is that each one. So if I make a whole bunch of these, a whole bunch of these slits that are round, these holes, you could get the idea that the light, and each one is creating the whole pattern. So each one is sending the whole pattern out. And it means that each photon has a probability of going to any one of these locations. So one might go to that location, one might go to this location, one might go to over here. So they go to every location when you send enough photons, but each individual photon, each little piece, only goes to one specific location, and you need a whole bunch of photons to build the whole image. But each slit is creating exactly the same pattern. It's not like this hole creates just this part and this hole creates this part. Just like with the slits, each one is sending the whole image to a location. And it's just that it sends it to locations where the neighbors are sending pieces also, and where they can be recombined back into an image. And so it's not likely that one from over here will be able to recombine with a piece from over here and recreate a photon. So again, all you're really trying to do is recreate the frequency. And when you have an object, and the idea, as I've pointed out, is that these things aren't arranged in a straight, perfect line. And so when they hit a particle of dust, one of these could get killed. So now you don't have the right frequency. And what you're really hoping to do is put another one back in that location. I mean, it could be down here, it could be anywhere, but it has to be in the right place in the to recreate the frequency. So they have to be in the right phase. So it sort of just means that if I had another photon here, okay, I could use the bit from way over here if I have a longer path. So this one's moving a longer line. It's a longer distance to get to this point. Point A, point B. And the one from point C takes a little longer to get there. So this bit could be used to fill this void, is really the point. So you're just remanufacturing the frequency. And so that's why you end up with this one pattern, is that it's all the locations where you can create that phase change, where now you took the third element from a different photon and put that in the second position of another photon. It just doesn't matter. You just need the energy to be at the right frequency. You need the little hits, the things to hit at the right frequency. And that's all that you're really matching. So you're just recreating a photon or not recreating. So if the phases don't match, that is, if this isn't a wavelength, precisely one wavelength of a longer line, then you can't put it in a new location. You can't put it back in phase. If it's a half wavelength of distance, then you'll end up with it here. And that won't remake your photon any better, because now your frequency isn't consistent. It goes from 300 nanometers to 100 nanometers to 300 nanometers. That won't work. That won't be seen as a photon, because it won't hit the electron the right way. So what else is there to say? It won't hit the crystal of the metal, actually. See, this whole thing is thousands of atoms big. So each little bit hits a specific atom, and the atoms make an effect that all happens at once. So it's a collection of atoms that are all doing the same thing at the same time on the other side that makes the new photon. Alright, well, I've sort of been over some of that. So the idea is that essential to the function of the interferometer is not smashing bits into each other and forcing them to interfere, essential to the process is merely just creating little changes, holes for the light to go through. The holes diverge the light, so one beam diverges through the whole mechanism, keeps diverging. And so you have to know too, like these are just obvious kind of facts, that this pattern is much more complex than they want to accept. So the first thing you have to understand is that when you half silver a piece of glass, okay, it's not really half silvered, because the catch is, you know that this piece of glass already is reflective, that something like 10% of the photons, at least, at this angle, at a 45-degree angle, you already know that at least it's probably more like 20%. 20% of the photons are going to reflect just off a plain piece of glass. So when you silver it, you're not half silvering it. Okay, it's much less than that, but you already have a reflective surface. So it's like 20% or 40%, so 30% silvered. Because what you want to add this up to, you want to add enough extra reflection to take this number from 20 to 50. Okay, so you want 50% of the light to go this way. So you add 30% of silver to add to the 20% the glass already creates. And then the catch is that you're sending this light through the gaps. Okay, the other 50% is going through the gaps, and the gaps mean it's going to diverge. So at the end of the experiment, you know that one beam has diverged through the whole experiment, and the other beam's only going to diverge through this little part here. And then what do they look at? They look at one little bit in here. So what percentage of this beam versus this beam are they going to see when they look at this little section, right? So when they're looking at this little section, you got to know that this is only 50. This is 50% of the light going over this huge area. This is the other 50% in here. So what beam is going to have more influence, obviously? Well, obviously, this beam's going to be very diluted. There's only going to be a few of this beam's photons involved, and most of the photons are going to be involved from this beam because it's spread a lot less. So all of this got spread right out of existence. Even though when it was going back and forth on these mirrors, say they shoot it back and forth through a bunch of mirrors and it goes back through the mirrors again, as it's doing that, it's starting to get wider and wider, more and more spread, and so it's spreading right past the mirrors even. This pattern is huge, this pattern is tiny. So you know that what's really controlling the experiment is mostly that one beam, the beam that reflected first and then came back last. You know that's the dominant beam in the pattern you're seeing. So it's clearly not 50-50, it's clearly the point. It's clearly not what they're saying, that you're taking two equal beams and measuring, and recombining them, phase and all this kind of stuff. Yes, you're recombining pieces, but this beam, because it's spread so much, you could almost argue that the only piece left of this beam is light going really straight. So the one that diverged, you could argue that the only part that you're gleaning is the photons that are going dead straight, because they're the only ones not diverging, right? So the ones that had to be very parallel. So now you've made this light very parallel. This beam, this is the parallel path. The light has to stay parallel to get back out. And this is the non-parallel half. So you have one beam that's very parallel, and you're going to combine it with a beam that's spreading, that's doing this. And those are the two phases you're going to match. So you're not going to be matching, this extra distance is what you're really measuring. This extra distance from your target, from where you're viewing. Because you want these photons to interact with this photon, for example. I probably should draw that side by side so it's more understandable. So the beam that was being spread is now the parallel beam. The beam that wasn't being, that reflected off the mirror and only went through the holes at the last, through the last mirror it goes through, is the beam splitter. The last thing it does is go through the beam splitter holes. That beam is spreading. So those photons are doing this, right? And now you're going to combine these two beams. And what you're going to hope Because they've both been damaged by going through the hole. So just understand, they both were photons going through a hole that's too small. They both had pieces knocked off their bits. So this stuff that's left over is like 3/4 of a photon, half a photon, 1/4 of a photon, little pieces of photons. And they all have phase. And now this line obviously is a longer line than this line. So now this one, you can take if this distance can equal a whole wavelength, then you can take a piece from this one that's out of phase and make it in phase with a piece from this one. So that will be the idea, is that you're going to try to combine path length differences that end up being, one wavelength out of phase, and then you'll get a photon. You'll make the photon again, which is, the photon is just a pattern and a ray length. So these are all just pointing out, these are theoretical, factual statements about what you know has to be taking place. You know that the half silvering is creating just like a dust, just like a piece of dust, it's creating an edge. And the edge means that photons will be diffracted because there's electrons on the surface. So I guess I should have pointed that out more explicitly. So a piece of half silver or a piece of dust, it just doesn't matter. All that matters is it creates an edge. And the edge of anything, whether it's a piece of silver on the mirror or whether it's a piece of dust sitting on top of the glass, they do the same thing. They both, on their surface, have electrons, and the electrons will deflect the light. And so they're both doing the same thing. It's the openings, it's the surfaces, so many times, but this is just a surface phenomenon. It's what light does when you push it through a surface, and the simple way to understand it is you already know that when light hits a surface, it's refracted, okay? It's bent by going straight in, all right? I mean, coming into the surface this way. Well, obviously, if you're sending the light this way, next to the surface, you would have some expectation that if it's a surface phenomenon that refracted the light, that it's also a surface phenomenon that's going to end up diffracting the light. If you go along the edge is going to be more likely to screw your light beam up than going straight through. Because if you're going straight through, you're only going to hit a few electrons. The odds are you're just going to hit one or two, right? You're going straight through. But if you're going this way through, well, you could hit this electron, you could hit this electron, you could hit a lot more than one electron. And that means you can deflect even more, because the more electrons you hit, the more diffracted you are. So each time you're sending a little bit of light in a cone, and then this. So if you hit one electron, you end up going here. You hit 2 electrons, you end up going here. One of these places. You hit 3 electrons, you end up over here. You hit 4, you end up over here. And that's your interference pattern. It's really just showing you what it looks like when you hit something. So in a way, you could say the circle pattern. See, it's really not the truth, though. In one way, you could say, yes, it's like I could put something here, and if I understood that it could bounce off in different directions, like if I put a round ball in front of me, I could understand the light could bounce off in these different directions. Kind of that's happening, but it's like the opposite. The real point is you have 2 solid things here, and it's this surface that's deflecting it. It's going around the outside of the ball and hitting the electrons between the 2 objects that's really causing the deflection. The closer the objects are to each other, the more the deflection, because the more energy the electrons have, and the further apart the little pieces of crap are, the less deflection there is. So the size of the particles really has to do with how likely it is the particles are going to be close together versus far apart, more surface. So the smaller objects are likely to have bigger gaps than the bigger objects. Is that the right way to say it? No, the bigger objects are likely to be more electrostatic. That is, their pressure of their electrons are likely to be, they're under less pressure. So the smaller the object, the more the electrons are under pressure. So the more deflection you get. Yeah, better way to say it. But anyway, it's this is like profoundly important to the whole idea of interferometry, is understanding this pattern. This pattern is all over the place, and it's like they've turned it in. See, these lines are really the same pattern. It's just that it's making a gigantic circle. So the size of the circle is just huge. So when you see straight lines, they're not really straight lines. They're really making just a gigantic circle. But this is the same phenomenon that really is the roots of a rainbow. Lots of things, this is the root of it. And they never connect any of these dots. They just say we have a beam splitter. It makes two equal beams. Not even close to the truth. It's not a fact. Okay, it's a huge inaccuracy, and it's hugely important. But you can see that's all they have. So this is the only amount of reference they have to one of the most important patterns in physics. 2 paragraphs. This is the guts of an interferometer right here, and they have 2 paragraphs on the subject. So just indicating they really don't know what they're talking about when they talk about these phenomenon, because they don't even go to the real source of the phenomenon. Like I said, the only paper you can find is 1980s. That has any detail on this whole idea of the dust experiments Newton did. It's the only place anybody even talks about it. So anyway, enough of a video. Till the next time, and such, and so forth and whatnot.